Welcome to the lecture series on vitamins and nutrition. Today we are going to look at vitamin K. The contents of today's talk would be on the historic aspects of vitamin K, and we are going to look at different aspects in terms of the sources of vitamin K, how vitamin K was established as a vitamin, and we are also going to look at various aspects of vitamin K absorption and distribution. So, if you look at vitamin K, you have to remember these two scientists, Henrik Dam and Doisy. So, Edward Albert Doisy, these two people have done a tremendous contribution in the discovery of vitamin K. So, if you look at it, the discovery of vitamin K had such an impact and it deserved a Nobel Prize. So, in 1943, Dam and Doisy, because of their independent investigation in vitamin K and its role in human physiology, shared the Nobel Prize in chemistry in the year 1943. So, if you could look at why they were called vitamin K, although so far whatever vitamins, especially fat soluble vitamins, we were looking at based on their historic chronological account, you start calling them like A was the first one being discovered and B the second series and so on. And this one has little correlation in terms of its function. So, you see over there vitamin K was originally called as its role, physiologic role that it played in coagulation. In German it is actually called coagulation vitamin. So, as Dam and Doisy were working on with the classical, I would say, experiments on chickens. So, what they did was they could now make a correlation with some of the published articles which suggested a coagulation vitamin playing an important role. So, what was this classical experiment? So, what they did, so they were feeding chickens with diet free from fat. So, they would ensure they will remove all the fat material in the diet and they supplied only a diet free from fat. So, it was even free from cholesterol. What they did was, after the chickens were fed for considerable period of time, the chickens started showing, I would say, symptoms of hemorrhages. Hemorrhages could be pinpoint, hemorrhages at the point where the tag sites of the animals were placed, and everywhere there were hemorrhages. So, they thought maybe the animals lack, I would say, cholesterol. So, they supplied the diet with cholesterol. In spite of it, they could not see any drastic change. So, eventually what happened was they started supplementing with, based on the published reports with other groups, they could establish a diet of extracts, and only in the presence of this dietary extracts hemorrhage conditions were reversed. Since this particular vitamin is playing an important role in coagulation, it was actually called vitamin K. This particular vitamin, I would say, is one of the well-known vitamin which is given as an antidote for warfarin therapy. So, now at this juncture I should tell you the function or the other alternate names for vitamin K. So, you could call it like anti-hemorrhagic factor, I would say specific coenzyme function, and then you see those factors which are required for coagulation. So, the moment you think of vitamin K, think of bleeding and you consider treating the condition with vitamin K. So, there are different aspects of coagulation pathway. We are not going to see that today. We are going to focus more on vitamin K, and when we are going to talk about metabolism of vitamin K, we are going to look into the details of clotting mechanism. Now, before I say this, I would tell you about one more drug which is an antagonist of vitamin K, because if you could look into the role of vitamin K as an antidote for hemorrhage symptoms of this particular drug, then it would be much more appropriate for you to visualize and relate this particular vitamin. So, there was this particular drug, even now this particular drug is available in therapy and it is called warfarin. So, this warfarin prevents coagulation. So, for people who suffer from clots, I would say embolism resulting in capillaries, it could be of many reasons, and this clot can migrate and can cause, I would say, vascular damages, and sometimes it can even cause massive cardiac arrest. So, warfarin is actually given to treat this condition as a blood thinner. Nowadays we use aspirin, low dose aspirin, but in certain conditions warfarin really helped, and even now warfarin is prescribed, but the use of warfarin is not so common as used to be, because you have other safe, I would say, blood thinning agents available. But warfarin is supposed to be one of the classical drugs acting like a blood thinner, and they also had a very narrow therapeutic index. What do you mean by that? So even at a very low dose, they can cause little increase in the dose, they can cause severe bleeding conditions. If something happens like that, who will come to the rescue? Vitamin K. So that way it is called anti-hemorrhagic factor. So if you are very much interested, most of this warfarin related chemicals are used as rodenticide even now. So rodenticides, like if you want to kill the cat, the drug what they give is actually a warfarin derivative, which will make the animal bleed to death, and the antidote is vitamin K. So this warfarin, which was originally a derivative from a rodenticide, was used in cardiovascular therapy as a blood thinner, and whenever the dosage became little higher because of its, I would say, minimal level, mini low therapeutic index, vitamin K was administered as an antidote. And you do have other pathways by which there could be bleeding or hemorrhage. So vitamin K is classically used in many therapies concerned with warfarin related toxicity. Now we are going to look at, I would say, into the aspects of the chemistry of vitamin K. So you do have, I would say, three category of vitamin K, what we call it like the naturally occurring vitamin K and the synthetic derivatives. So natural vitamin K basically comes from two sources, phylloquinone and minoquinone. Then you have menadione. So menadione is basically the synthetic derivative, what we call it like K3. Menadione is supposed to be very potent, but you should also be careful because menadione can actually cause severe toxicity. So whereas the dietary sources, the natural sources, you always get it from K1 and K2. So if you look into the structure, you will find a lot of interesting things, and yes, as we know, vitamin K is a fat soluble vitamin, so it's a lipophilic hydrophobic vitamin. And you have, like, structurally you look at it, so what is the difference you see over there in this structure, structure A, phylloquinone? So you see this, you get it from a normal, I would say, vegetable source. So you see over there you have a side chain, and probably I should show you this structure. So you see there menadione basically is this core structure. Okay, so quinone is there, it's a naphthoquinone. You see the naphthoquinone derivative, and phylloquinone, which is K1, and here you have the basic ring structure, and in that you find in the third position there is a side chain attached. Okay, so this linear side chain can be, I would say, double bonded. In case with K2 you have, I would say, K3, there is a difference. See, for example, in K1 and K2 and K3, the difference occurs in the type of side chain attached. In case with K4 you do not have any side chain, whereas you find a side chain with alternate double bond, or rather with the isoprene unit kind of an appearance, whereas here in the K1 phylloquinone you don't find much conjugation, I would say alternate double bonds in the side chain, whereas it's very prominent in the K2, and in K3 you do not have side chain at all. So the K3 is the synthetic one, much easy to synthesize because this core nucleus has an excellent vitamin K property, whereas K2 basically comes from intestinal bacteria. So they synthesize the side chain of variety of, I would say, alternate double bond or a conjugate system. So you look at it, you have the 2-methyl-1,4-naphthoquinone. So this is basically the core structure. Okay, so the basic quinoid nucleus we call it, 2-methyl-1,4-naphthoquinone. Naphthoquinone, the third position, fourth position and third position, especially in the third position you have the side chain attached. So you see over there, and this is how we actually differentiate them. So here when we consider, you have menadione 6, 7, it indicates like K2, K6. So 6 and 7 implies how many isoprene units that you have, and the 30 and 35 indicates the number of carbon atoms. So we call it like K2. Then you may have prenyl ring or isoprene rings. So you may have more extended isoprene rings as well, which has property, but structural activity relationship says that if you do not have any side chain, they become extremely potent to a point that they can even cause toxicity. So that's why we have to be very careful in giving vitamin K supplement to treat conditions. It's quite rare people suffering from vitamin K deficiency as such, but mostly it is given as an antidote, because many dietary sources that we consume have plenty of vitamin K, and I would say plenty of fat soluble vitamins would be there. Now if you look at the daily requirement, you see over there the daily recommended intake. So you have different stages. So for an adult, let's say 18 years old and above, you have for male 120 microgram to 90 microgram is the normal requirement. So you don't have like any specific, I would say, requirement needed during pregnancy or lactation, although for other vitamins we saw their role plays a very important role. So this is like an average intake. So we normally don't even know that how much we are taking from our dietary sources, and in most cases we are well supplemented with vitamin K. So here we have lot of natural sources. So you see there, one thing can you see in common, you do have lot of green color. So all the green vegetables are a natural source. So here you have egg yolk, liver, and margarine, which is saturated vegetable oil, which is otherwise the vegetable oil butter. So everywhere you find a very good source of vitamin K. And if you look at, so how or what bacteria, especially the gastrointestinal probiotic bacteria, are responsible for making vitamin K12. So K1 and K12. So here you see phylloquinone is basically K1, and K2 menadione are basically, I would say, vitamin K2. So you see there cauliflower, cabbage, okay, fruits, broccoli, and yeah, you do also have a dietary supplement of vitamin K given. So if you look at it, what precautions you could check? Yes, they do not remove much, because most of the fat soluble vitamins are not thermolabile as you could consider with water soluble vitamins. So you see, if you could do lots of freeze thaw cycle, yeah, you do have problems with vitamin E content or the potency. So whereas if you could like really cook them, yeah, they don't lose much. Whereas if you say, if you are going to look at freezing them, the freeze thaw cycle would really have an impact on vitamin K. So here we have, I would say, how vitamin K is absorbed. So this is much close to vitamin D and other fat soluble vitamins. So always remember, whenever we talk about fat soluble vitamins, mandatory you will be considering bile salt and bile secretion, because without its participation, the micelles, the small tiny globules of fat soluble vitamins, cannot be dispersed, emulsified, and without that, absorption would be drastically impaired. So you see there, normal pancreatic and biliary function. So you do have this problem. Normal pancreatic and biliary function, we don't have much deficiency occurring when people are eating a balanced diet. So you see over there in the luminal micelle formation, okay, it means actually speaking the globules are broken into very tiny particles, and the bile would cause or maintain or stabilize the micelles, and then across the gastrointestinal tract they are absorbed. So phylloquinone is absorbed by a energy dependent process from the proximal small intestine. So phylloquinone is basically the plant derived source K1, because whenever you are talking about plant derived sources, you have to crack open the cells and release the contents, whereas from other sources it's relatively easy to acquire. So that's what we see you have a different pathway which is an energy dependent process in the proximal small intestine. Now they are transferred to lipoproteins because they are all fat soluble in nature. How you are going to like really transport them? Once you convert them into micelle, they will be coated with lipoprotein, and here you find minaquinones and minadione are absorbed strictly via non-carrier mediated passive diffusion. What do you mean by non-carrier mediated passive diffusion? So in a carrier mediated, a carrier would transport the component across the cell, but in a non-carrier system, as you look over here, there are no direct mediators, but by passive diffusion. When the concentration is higher outside and the concentration is less inside, directly across the membrane it could go inside the cell. Yes, obviously when you are talking about passive diffusion, the rates could be affected by micellar contents of lipids and bile salts. So it means like how much amount of bile salt was like really invested in making the globule into a micelle form. So this kind of passive absorption you find in the distal part. Distal part, it's like towards the end of the small intestine, where it would be reserved to observe these micelles in effective sizes so that they can go into systemic circulation. Now, so you see that there are no specific carriers for vitamin K, and you see the plasma levels of phyloquinone. Okay, so normally you find them very close with triglycerides and tocopherols. We saw in the previous session about vitamin E. So you see that the plasma concentration is somewhere around 0.1 to 0.7 nanogram per ml. So how do you take it? So normally it is rapidly taken by the liver the moment it goes into tissues. Liver being one of the primary organs for storage of many of fat soluble vitamins. So that's why we should not tax liver too much. So liver has already its load of all dietary xenobiotic components going to it, and in addition to that you do have other endogenous metabolites which are released, and also many components as food substances which could be sourced from a natural route, or it could be some synthetic, I would say, stabilizers in the food. Everything will go to liver, and liver would do the metabolism to make it more water soluble. So here again, if you look at vitamin K, there is a vitamin K dependent coagulation proteins. What do you mean by that? So there are many coagulation proteins which play a very important role in the clotting mechanism, and vitamin K mediates their function. So that's what we mean. So if vitamin K is not there as part of dietary availability, then all these functions connected with coagulation pathway might suffer. So that's one of the reason if people have any problems connected with bleeding conditions or let's say anemia, they should also check for the validity of vitamin K levels in their blood. So that could be one of the reasons why there is this cause of deficiencies and bleeding conditions available. Now you see there hepatic storage of vitamin K has little long term significance. So that's really good. So vitamin K is rapidly removed from the liver and rapidly excreted. So what do you mean by that? Liver acts like a kind of a reservoir where all the fat soluble vitamins could go over there, reside there, where they are channeled and distributed across, and eventually if there is any kind of abnormality concerned with that, the liver would take care and would like immediately degrade it with a group of enzymes and all the active cytochrome family of enzymes in the liver cells. So you see over there, as it's being distributed across, you find it in the adrenal gland, you find it in the lungs, you find it in the bone marrow, you find it in the kidneys, you find this in the lymph nodes. Yeah, their concentrations might vary depending on this organ, but it's like distributed everywhere. And if you could make one close connection, all these organs have been like highly perfused with blood vessels except for lymph nodes, which are very close towards the capillaries. So you see transplacental movement of vitamin K is poor. So what do you mean by that? Transplacental movement. So means like from mother to child, many of the nutrients would pass away, but for vitamin K it's going to be little troublesome. So you see it's not like frequently detectable from the cord blood from mother. So it means what? You could always consider there is a basal level vitamin K deficiency, maybe in the newborn or at least in the neonatal, but as you could really look at it, there would be, I would say, compensation of other components, and that's one of the reason when we look at any classic conditions of bleeding could be a problem for a neonatal which is less than a week old. So this is one of the reason, because there is no sufficient, I would say, levels of vitamin K could be stored in the liver of newborn. They are more susceptible for hemorrhage and bleeding conditions. Okay, so that's why newborn are susceptible to hemorrhages. So if you look at certain practices among Jewish people or even among the Semitic people, so they recommend circumcision only after day 8. So the reason is they give sufficient time for the clotting factors to be formed, and also a dietary intake of vitamin K could be made available to the newborn. So only after a period of 7 days later they are eligible, I would say, even to undergo circumcision. So you see over there, here it is transported from different tissues. So in the previous slide I told you it goes to lung, bone marrow, kidneys, lymph nodes, and then what happens, it gets distributed in the tissues. So you see in the endoplasmic reticulum, in the mitochondria, you find all these, I would say, organelles inside the cell where vitamin K would be distributed. So you see that the vitamin K appears to be depleted from the cell membrane more slowly than from cytosol. What do you mean by that? So there is always a positive, I would say, load of vitamin K available, and this load of vitamin K would be distributed across for the normal functioning. And actually if there is a slow, I would say, deficit in the amount of vitamin K availability for a particular individual, we may not even see the symptoms until they really gradually show up, that kind of a cumulative deficiency symptom. So you see there how it is metabolized. So now vitamin K goes to liver, and here you have a lot of microsomal enzyme systems in the liver hepatocytes that will handle the modification of side chain, because you see you have a lengthy isoprene kind of a unit in the 4th carbon ring, and this could impart that hydrophobic nature to vitamin K. And then you also have to disembark those functional domains and I would say retain them some, and thereby making it more feasible for metabolic activity to happen for vitamin K. So you see that there is dealkylation and alkylation happening, which is fundamentally a side chain modification. So what is dealkylation? So whenever you are going to remove an alkyl group from the side chain, it's called a dealkylation. So the metabolic dealkylation of phylloquinone side chain, it means converting it to, I would say, menadione. So how do we do it? The metabolic dealkylation of phylloquinone side chain, it's followed by realkylation. So it's something like you remove the alkyl group and you fix the alkyl group. Okay, so in such a way you could make these changes and make it more compatible for oral administration. So in case with emergency where you have to like really treat the patient immediately, they go for an emergency of vitamin K, but in a long term basis to treat deficiency diseases, they recommend oral intake of vitamin K. That's what we consider. The alkylation of menadione does occur in vivo. So menadione is supposed to be the synthetic derivative with no side chain, and then you have the main product of the alkylation of menadione is MK4. So what do you mean by that? How do we look at it? So vitamin K in that case is subject to the cycle of oxidation and reduction that is coupled to carboxylation of the peptidyl glutamyl residue. So what do you mean by that? So now I want you to be aware of how this clotting mechanism happens. Especially primary aim of any clotting mechanism is you want to like seal that path where the blood flow keeps coming, and you have to rely on those components where you have to like mesh it up. So that's one of the reason why the coagulation pathway is quite complicated. Now we have worked out most of the components in the coagulation pathway, but if you closely observe, it's not only, I would say, the components involved, but the cascade in which this happens is also quite interesting. So that's why we consider there is a very systematic way in which the liver would handle vitamin K as part of its biotransformation related functions. So you see that there is this gamma carboxylated proteins, you say peptidyl glutamyl residues. So this peptidyl glutamyl residues creates that fundamental cross linking. So it's all the glutamyl residues present in the protein side chain that plays a very important role in creating the cross linking. So factor X, for example, is fundamentally a cross linking agent. This catalyzes the reaction. We are going to look at how this basically happens, how we are going to like really prepare it for detoxification. So the first one is like oxidation of dihydroxy vitamin K to vitamin K2 3 epoxide. So we are elaborating this in 3 steps: the oxidation of dihydroxy vitamin, then reduction of 2,3 epoxide to vitamin K quinoline. So you see that it's all about you are really initiating an epoxide related function, then followed by, I would say, reduction mechanism. We are going to see that, and you are going to look at after that the active dihydroxy vitamin. So basically it undergoes a very systematic level of activation before they could be like really inducted into the actual function of cellular support. So you see that the final reductive step can be catalyzed in 2 ways. So the pathway is quite extensive. In any case, their interaction directly with the clotting proteins ensures its physiologic response. So you see that in this particular component, you see the final reductive step can be catalyzed in 2 ways. So vitamin K quinine reductase, a dithiol dependent microsomal enzyme. So there are many enzymes in the liver that would do this job. So today we are going to conclude. We have seen historic aspects of vitamin D, their dietary sources, very simple introduction to its deficiency conditions, and directly we plunged into the absorption and distribution aspects of vitamin K, and we are into the biotransformation of vitamin K, of how active form of vitamin K could be made available. Thank you for your attention.